Good morning. What a crowd. We speculated when Google I/O sold out in 59 minutes. By the way, congratulations to all of you who set places in your calendars that you were going to get an I/O ticket this year, no matter what. It's a great testimony to the excitement about Google technologies and APIs that you're all here, and we're very glad for that. But when we sold out so quickly, there was some speculation. Is this because people just want the free phones or devices? And the fact that we have over 200 people here in this room, standing room only, to hear a talk about GWT says to me, no, you came for the code. So, all right. So thank you very much. My name is David Chandler. I work with the Google Web Toolkit team in Atlanta, and we're going to talk this morning about some third-party tools that you can use for productive GWT development. And with that, we'll go ahead and get started. So first, we're going to talk about third-party tools in general, and then we're going to speak about Objectify-App Engine, which is useful on the server side. Then I'm going to cover the new RequestFactory features in GWT 2.1, and then Philippe Beaudoin will talk about the gwt-platform framework for MVP development. So we want to mention some third-party tools that are useful. Google can write a lot of code, but we don't write all the code. We rely on third-party open source projects to do an awful lot, and of course we contribute to get those things started as well. But one tool that you can use for GWT and App Engine development is Maven. And I just want to highlight, because there were some issues using Maven with Google plugin for Eclipse in the past, we've made a big effort to make those work better together. And you can now import an existing Maven project in Eclipse, and your Google plugin for Eclipse stuff will be all configured. With your App Engine SDKs will come from the Maven POM, as well as your GWT SDKs, and it works much better than it has in the past. So this is a great, thank you. So let me ask, how many people use Maven? Okay, lots. How many people love Maven? Okay. How many people hate Maven? Some of the same hands. All right, we understand, but it's a useful tool, so we want to try and support it as best as we can. And two third-party projects that are very important to that are the Maven GAE plugin and the GWT Maven plugin. And we're really glad that they took this on because they did those plugins before we supported it in Google plugin for Eclipse. And we rely on the community for this, so that's great stuff. Now, on the App Engine Datastore side, there have been, besides the JDO and JPA interface that Google produces, there is Twig, Slim3, SimpleDS, Objectify. There's lots of different frameworks that have been developed to help people with persistence. And then on the front-end side, lots of model view presenter frameworks, MVP for G, GWT Presenter and Dispatch, and gwt-platform are frameworks you've probably all heard of. So these are just some tools if you're getting started researching these topics. Good places to go and look. So what we're going to do this morning is kind of work from back to front. We're going to start on the server side, talk about the App Engine Datastore and Objectify, a framework that can help you there. Then move up to RequestFactory, which is GWT's new RPC layer. And then at the top, we'll have gwt-platform and how you can use it to build model view presenter UIs. So with that, I'm very pleased this morning to have with us the creator of App Engine Objectify, Jeff Schnitzer. Jeff, please come on up.
Hello? Oh, it worked. Where's the clicker? All right. I'm going to give you a very, very brief introduction to what I'm calling the simplest convenient interface to the App Engine Datastore. But first I have a little confession to make, and that's that I hate writing tools. I'm an entrepreneur, and every day that I spend writing tools is a day that I'm not adding a feature to an application that might someday make me rich and successful. But I use a lot of tools, and it's very important to me to use good tools. If you ever walk into the back of the workspace of an automotive or a motorcycle mechanic, you'll find, well, first, a number of posters of half-naked women. But second, you'll find a big box of Snap-on tools. Snap-on tools are very expensive. A wrench that will cost maybe $10 at Sears will set you back about $50 from Snap-on. And there's nothing wrong with the Craftsman tool. I've got a garage full of them, and let me tell you, they turn bolts just fine. But if you hold the Snap-on tool in your hand, the polish is a little bit better, the weighting's a little bit better. It's just slightly nicer ergonomically. And if you spend every day of your life working with tools, when you have slightly nicer tools, it actually improves your quality of life. So when I started working on App Engine a year and a half ago, I started out with JDA and JPO. JPO and JDA. Yeah. Well, my quality of life was not good. This kind of surprised me because I'm actually a really big fan of JPA. I've been doing Java EE development professionally for about a decade. I've been using Hibernate since version 1.0, and I've got Gavin King on speed dial. But still, it was a struggle. And I tried to figure out why. I realized that there's two basic problems. One, there's a lot of stuff in JDO and JPA that just don't really apply to App Engine. And second of all, there's a lot of stuff in App Engine that just was never accounted for when they designed JPA and JDO. You can't develop an application on App Engine without understanding at some level how keys work, how entity groups work, and the particular quirks of indexes on App Engine. And because of this, there's 4 learning curves that I had to climb. First, how do you represent your Java data structures with JPA or JDO? How do you manage the giant data nucleus software package, which implements that? There's actually the data nucleus plugin that Google writes that maps from whatever they put out on the back end to the low-level data store. And then there's how should my data actually be represented natively in the data store itself? To make this especially fun, the documentation for all of these learning curves is spread out all over the internet. And so I was running to and fro different websites. When I took a step back and said, okay, this is crazy, I realized the only one of these learning curves that really matters is how should my data look in the data store? Because this is what controls what is my application going to cost? How long is it going to take my queries to return? Will I be able to get the answers to my queries that I want? So of course I went straight to the low-level API, which at the time was documented only in Java docs. And I realized something. I realized that the App Engine data store is actually really simple and really elegant. There's really only 4 operations. You can get data out of the data store, you can put data in the data store, you can delete it, and then you can query for it. And the low-level API is not really all that bad. You've got these simple entity data structures. It's basically a hash map. You can keyed by string, you can put some data in, you can take some data out. But it's a little bit too simple for all the reasons that we invented compilers and type checkers. It's really not very pleasant working with hash maps. And the data store itself has a few funny quirks. If you put numbers into an entity, it'll always come back as a long. If you put a set of data into the entity, it'll come back as a list. So what I really wanted was just objects. We're used to working with objects. Nice type structures. So I decided that I'm going to write a thin layer that works just like the low-level API does, but that lets me work with objects. It simply objectifies the low-level API. And so here is an example of an Objectify entity. There's only one required annotation. You have to give it, you have to define an ID. And it uses the ID annotation. Other than that, you can use enums. You can have almost any type involved you want. Getting an entity out of the data store is very simple. You pass in the class and an ID, and you can get back the entity. There's also a batch operation for doing this. Putting data into the data store. Create an object, put it in the data store. There's a batch operation as well. Deleting entities, simple, straightforward. There's also And as you can guess, there's a batch delete operation. And for any of you that use the Python version of App Engine, the querying API should seem very simple, should seem very familiar. So that's the briefest introduction to it. A year and a half later, there's been quite a lot of new features added. I'm not the only one committing code anymore. We've added asynchronous operations, true polymorphic queries, so you can ask for all the mammals and get back the cats and the dogs, but not the lizards. Partial indexes, parallel transactions, embedded objects and collections, serialized object graphs, and then two things that I use a lot. Automatic mem caching, so if you just put a little annotation at cached on your entities, they'll automatically be pulled efficiently in and out of the mem cache. And a set of tools which we've sort of worked out over time are necessary to make fairly radical schema changes. They allow you to make fairly radical schema changes without experiencing any downtime whatsoever. And with that, I will hand off to the next presenter.
Thanks very much, Jeff. So let's talk about the middle layer now. In 2.1, GWT put out a new RPC layer called RequestFactory. And I want to use this time to introduce RequestFactory to you, and then also show you how it can be used with Objectify in a GWT application. So there are 4 ways of doing RPC in GWT. We've had for a long time the request builder with either the XML parser or the JSON parser. So you can connect to any XML or JSON feed via XML HTTP request. There's GWT RPC, which allows you to send and receive POJOs on the wire and automatically handles the serialization and deserialization. And most recently, we've introduced RequestFactory. And you might ask, well, why did we need another RPC framework in GWT? A lot of people are using GWT RPC very happily. And the answer is there's a few limitations or problems, especially when you get larger applications using GWT RPC. One of them is that GWT RPC creates a custom serializer and deserializer for each class. Sorry, not custom, it automatically generates it. But there's one per class. So if you have a lot of classes that you're sending and receiving over the wire, you're going to get a lot of extra JavaScript to do all that serialize, deserialize. And this can also lead to what we call accidental type explosions, where because it supports polymorphism, if you use an interface type like list and send that over the wire, GWT RPC has to create a serializer and deserializer for array list, linked list, and all the concrete types of list. So that adds to compile time as well as to the size of your resulting JavaScript. And then finally, we've been talking in recent years about the command pattern and recommending the use of that in GWT applications. And GWT RPC doesn't support it directly. Now, there are excellent frameworks like GWT Dispatch that do implement the command pattern in GWT RPC, but it's a little heavy class-wise, as we'll see here, and it's not built in. So RequestFactory neither uses nor replaces GWT RPC. It is its own thing entirely. It's actually based on JSON under the covers, but we have our own protocol that we add on top of that. It's designed for data-oriented services, so it's especially well suited for persistence layer type services. It doesn't have to be, but it has that concept in mind. It acknowledges the DTO problem. So one of the things that faces developers when you try to send your objects from server to client is a lot of your server-side entities, whether they be JPA, JDO, or Objectify, or something else, they're going to have annotations in them that have meaning for the server-side framework. But GWT is a Java to JavaScript compiler. So in order to do that JavaScript compilation, we have to have the Java source for every bit of Java code. Well, the GWT compiler doesn't know about the Java source for JPA, JDO, and Objectify, for example. So you wouldn't be able to serialize those objects properly and send them back and forth. So there are several ways around this. One is to use GWT's supersource capability, and in the Objectify actually supports that. There's other frameworks like Gilead for Hibernate that will make GWT aware of source, even though it's not the actual server source. They'll make GWT think it has the source for an annotation, say, so that it can be used on the client. And that's nice. It's very convenient because then you can send the same object, just have one representation of your entity, and send it back and forth. But there are some difficulties with that as well. There have been recent changes to the App Engine Datastore key structure, which make that more difficult. And also, you can get, sorry, I lost my train of thought there. There's some kinds of server-side activities, right, which you just may not ever be able to represent in GWT. And so, at some point, you may have to use DTOs, right? But what's the problem with DTOs? The problem is that now you have two representations of your entity, which is a pain. And also, you have to manually copy on the server side when a request comes in. You have to copy from the DTO to the real server entity, and then when it goes back out, you have to copy the properties from the real server entity back to the DTO. There's a lot of boilerplate type stuff required to do that. So RequestFactory acknowledges this problem, and it uses the DTO pattern, but in a very lightweight way. What we do is allow you to define an interface on the client side that represents your entity. And so you only have to worry about the signature, if you will, of the entity, just the getters and setters. And then the RequestFactory code takes care of automatically instantiating that interface and populating all the getters and setters for you so that you're not having to do that tedious type of copy code. So that's one benefit. Another one is that RequestFactory is at a higher level of abstraction. So you can use the command pattern. It's built in with the request object. It already provides batching. In 2.3, you can batch requests within services, and 2.4, you'll actually be able to batch across services as well. We enable the RPC persistence layers to be created with minimal boilerplate, as you'll see here this morning. And then RequestFactory also tracks changes to your entities on the client side, and it sends only diffs to the server. So you get some payload shrinkage becomes possible because of that. Also now, we're happy to announce that RequestFactory has gone mobile, and you can write one RequestFactory service implementation, host it on App Engine or some other platform, and consume that service from both a GWT client as well as a native Android client. And to facilitate that, we've moved RequestFactory out from underneath the GWT package structure into com.google.web.bindery, so it can be shared by Android code as well. And we think that's going to be attractive for a lot of people in the near term who still need a richer user experience than you can get with a GWT app on mobile, although we're improving that as fast as we can. But if you have a native app, this makes it easy. At least you only have to write your service side once. So let's take a look at what it takes to get started with RequestFactory here. First of all, in your GWT XML, you need an inherits to bring in the module. You have to map the RequestFactory servlet in your web XML. And then what you're going to do is create DTO interfaces representing all your entities and value types. We'll talk about that in a second. You'll have your service stubs, just like in GWT RPC. It's just an interface. You have RequestFactory class, which extends the GWT RequestFactory interface, and that's what ties it together and tells about all your services. And then finally, to make it all happen, you just gwt.create your RequestFactory class. So let's talk about some concepts, terminology, define some terms here. An entity is something that has ID and version. So it's probably like a car and a fleet represented in a database, and it's likely represented by a row in a table. A value type would be more like a column in the table. It's something that doesn't have ID and version, maybe the color of the car. Now, proxy type is our RequestFactory term for the interface that you create on the client side to represent one of these server-side entities or value types. And the proxy types are shared between the client and server, and as we'll see in a moment, they're in a shared package. The RequestFactory code in GWT automatically creates and tracks instances of your interfaces using the new AutoBeans framework. And this is available to use for other purposes if you want in GWT, but it happens to be the plumbing behind RequestFactory. And a little bit about what this means is that the RequestFactory will actually create an instance of an interface. You think, well, wait, how can you do that? You could do it using an anonymous inner class or something, but that's not what I'm talking about. You'll see in a minute, you can just call service.create and give it your interface type, and you'll get back an instance of that interface. Because RequestFactory actually creates the instance, it can register visitors. It supports the visitor pattern on your instance. And so it knows whenever a setter has been called on your entity. And because it is able to know when the setters have been called, it can determine when there's changes. And this, in fact, is what allows RequestFactory to keep track of changes and send only changes to the client. So by giving RequestFactory control of creating your instances, you're allowing it to do smart things for you. Then finally, a service stub is just our service interface, analogous to our remote service class in gwt-RPC. In RequestFactory, it's called request context, is the class that you'll extend. So on the server side, and I'm trying a little color coding experiment here this morning. I apologize if you're red-green colorblind, but we'll try to use position to indicate it as well. But we're going to you can remember RGB, server shared client, RGB, going across. So on the server, things are red. This is where we're going to have our entities and our service implementations. We'll also have something called locators, which we'll talk about a little bit later. In the middle, we have the shared package, and this is all just interfaces. And then our actual client code that calls RequestFactory services is in blue on the right. So let's look at an example of an entity and entity proxy. On the left, we have a named list. This is an entity that uses Objectify annotations. So we have the @entity and @ID in it. It lives on the server side of things, and it has some code in it which is not understandable by GWT on the client. Namely that key type there, which wouldn't be transferable across the wire. Notice that the proxy now lives on the right side. Named list proxy is just an interface. Interface named list proxy extends entity proxy. And it basically just defines the public signature of our entity on the client side. So just the getters and setters. And you can notice also that the proxy has to refer to other proxy types. So instead of referring to an app user, which would be a server-side entity, it has to refer to app user proxy. And instead of referring to list item, it refers to list item proxy. So everything on the client side, you're going to add proxy, generally, when creating your interfaces. RequestFactory automatically takes care of converting between the proxy types and the real types on the server side. Now, notice that our entity proxy on the right side also has a proxy for annotation. This is how you tell it which server-side class it represents. In this case, it's named list. And it also has a locator here, which we'll talk about in a second. So all of your built-in value types, basically string and your primitive wrapper types in Java, like string, integer, Boolean, et cetera, are automatically handled by gwt-RPC. You don't have to write anything special. Enums are also supported. So in our proxy interface here, we've defined an enum list type, notes and to-do. And we don't have to do anything special to serialize that across the wire. It does not have to be located in the proxy type. It can be located in anywhere in a shared package. And on the server side, RequestFactory doesn't, it just ignores the annotations. RequestFactory itself isn't concerned with that. Those are purely there for Objectify in this case. And then finally, notice that we can send an embedded list of items. So we're using the embedded annotation to send a list of items, and what that will do is store the items in our list along with the list in the Datastore. This is the Objectify annotation. It's a powerful feature to be able to store things together as a package in Datastore. So that is an entity proxy. Fairly simple, just an interface. Value proxy is even simpler because value types don't have ID and version. So here, a list item, which is being included in the collection of items in our entity, just has a proxy for annotation that identifies the server-side class. And note also we can use @proxy_name. So if you do @proxy_, it's actually looking for the Java type, which means that Java type has to be on your class path. But a lot of projects, especially larger ones, will split their GWT project into two separate projects, one containing the client-side and one containing the server-side code. So you may not have the server-side types on your class path in the client. And if that's the case, you can use proxy_name, give it a fully qualified class path as a string, and then RequestFactory will be able to find it still at runtime. Okay, let's look at our service definitions now. The service stub, you see at the bottom, we're defining a named list service. And this is just a basic CRUD service for our list object. It references the service impl, which in this case is called named list DAO. It happens to be a data access object. And we have a locator we'll talk about. It just extends the request context interface. And then all of the types all of the methods return request objects. This is what supports the command pattern in RequestFactory. And then the request object is parameterized with the real return type. So on the server, your implementation of this service is going to return a list of named lists. But the client interface has to say request parameterized with list of named list proxy. Okay, so there's a little mapping going on there. And we're going to be bringing out tooling in Google plugin for Eclipse that will give you warnings when your server interfaces or your impls don't match your interfaces, et cetera. Right now, that's a weakness of this, is that you have to manually keep those things in sync. You'll get runtime exceptions if they don't match. Oh, sorry, so at the top, we see the RequestFactory. This is what ties it all together. If we define multiple services, then we would have an accessor method for each one in our RequestFactory interface. Here, for compactness, we only have one. And this is just a marker interface that lets RequestFactory know it has to write some code for all these services. So how do we use it? Well, once we've defined our interfaces and our proxy types, we do a gwt.create on the RequestFactory. This causes gwt to run a bunch of generators, which generate the actual code that's going to make the service calls, et cetera. We create our entity using the service.create method that's on the request context interface. We give it our proxy type, and we'll get back an instance of that object. So in this case, a task proxy. We can then call it setters, and then call our method to persist the task. That would be a method that we define in our service interface. And then finally, fire it. And fire it is equivalent to your async call in gwt-rpc. This is what actually makes the call to the server. And just like gwt-rpc, you had to pass an async callback object. Here we pass a receiver. That's RequestFactory's terminology for your callback. And it has onSuccess, onFailure, and onViolation methods similar to gwt-rpc. And finally, note that when you've made a call to the server and you get data back, then there are entity proxy change events that get fired if RequestFactory determines that something has changed on the server. And this is why entities have the concept of ID and version in RequestFactory. So you can update the version. You're responsible to update the version on the server side. And when RequestFactory is returning a response and it detects that the version has changed, say from 3 to 4, then it will trigger this entity proxy change event on the client. So you can listen for that in your presenters or widgets or other classes to make updates to the UI. Okay, so let's look at some code, how it all works together. This is a method that will create a new list object and persist it on the server. So we do requestContext.create, give it our interface type, call the setters, and then save and return is our method on the service. We fire it, we pass it a receiver, and we implement the onSuccess method that will do something. In this case, we're updating a data table with our new cell table structure. Notice that we only have to implement the onSuccess method. With gwt-rpc, you also had to do onFailure. There's default handler for failure in RequestFactory, so we don't have to do that. But you can always, of course, wrap the receiver object. You can extend it and provide a default implementation of your own for onFailure or any other method. Okay, here's an update. Now, this is important. When something comes back from the server with RequestFactory, it is immutable. It cannot be changed. And in order to tell RequestFactory that you want to make changes to it, because remember, we want to track those changes, you have to call a method explicitly to do that. So you're going to call requestContext.edit and pass it the object that you got from the server. And that makes it editable. You can then call the setters and fire a request. Okay, let's look at a query. This one is going to receive back a list of objects from the server, and it calls the list all method, and then you'll notice there's this .with. So one of the issues with gwt-RPC was that it would automatically bring back a whole object graph. And as your object graphs become large, this can be problematic, especially in Internet Explorer. There's various bugs and issues you can find on that. So with RequestFactory, we wanted to give you control over exactly which properties in the object graph you want to bring back. So to do that, you use the .with, and you just specify the names of the properties that you want to retrieve. So you can specify a comma-separated list, and you can also use dot notation to drill down more deeply into your object graph, and it'll walk that and bring back only those items. So this is required to bring back any proxy types, any entity-related DTO property, so entity proxy or value proxy, you have to use .with. If you don't, all you're going to get back is the built-in value types like the string and integer properties for your entities. So a little bit more RequestFactory goodness here. Validation is supported now on the server side. You can annotate your entities with the JSR 303 bean validation annotations like @not null and length. And prior to invoking a service method, RequestFactory will call the validation API, will validate all the entities, and will return any validation violations to the server, to the client, and you can handle them in your onViolation method. That'll give you a set of constraint violations that you can then handle. So this happens before any action is taken. If there are violation constraints, then RequestFactory will just abort the action and won't actually invoke the method on the service, on the server side. Some more goodies here are the new editor framework, which unfortunately we don't have time to go into this morning in depth, but with editors, you can do data binding. So this automates the process of getting information from the view to your model and vice versa, the boilerplate type of code that's usually required there. There's a good sample app for this in the Dynatable RF, and basically the editor will take away a little bit more of the boilerplate code common for updating persistence UIs. It will also automatically give you the property list for your .with clause, so you don't have to manually specify that. It will infer that from the things that have been changed in the UI, and then send with all those properties listed to the server. So putting it together now, let's look at how you can use RequestFactory with Objectify to build a pretty lightweight persistence layer in GWT. You can annotate your entities with Objectify, define your entity proxy interfaces on the client, and then the cool part is we can expose our DAOs directly as RequestFactory services. So if you think about what you've done with the command pattern, maybe using gwt dispatch or something, the command pattern can be kind of verbose. So you have action and a result for each command, which corresponds to one method on a service. Then you also have an action handler on the server side, and then your DAO and entity. So to define a basic CRUD service with 4 methods in the command pattern, you would actually end up with 14 classes. To do that same thing in RequestFactory, by just exposing a DAO directly as a service, all you need is your entity proxy and your service interface. And so you end up with 2 classes and 2 interfaces. So let's look at an example of that. On the server side here, we have our named list DAO. This is our service impl. We're actually exposing it as a service to the client. I've just shown one of the methods here, the save method, to persist it to the data store. And then on the client side, we represent that as our named list service that extends request context. Just defines the method with the signature using a request for the return type. And that's it. You define your DAO, you define your interface on the client, and that's it. That's all the wrapper code you have to write to actually expose a DAO as a service. So for persistence-oriented services, this is really ideal because it gives you a very quick way with little code to implement CRUD services and the like. So the plumbing that's required to make this work are the locators, which I've been deferring until this point. So RequestFactory, in order to infer things like version changes on the server, has to be able to locate or find your entities. So in the original 2.1 implementation of RequestFactory, you had to provide static finder methods on your entities themselves. But that wasn't a very flexible pattern. It made it difficult to work with dependency injection on the server side. And it's not a common pattern. So in 2.1.1, I think it was, we made it possible to define a locator for an entity. And the locator, its whole job is just to find it. So it makes the call, the query to the data store, and brings back the entity. Well, because Objectify uses generics well in the DAOs, you can actually write one Objectify locator that will work with all your objectified entities. So only one class to make all this come alive. And similarly, for the services, RequestFactory originally would actually call static methods, and those would be your services. But that doesn't work with dependency injection at all, because you need instances of things. So in 2.1.1, we made it to where you could specify a service locator, and that would give you back an instance of a service. So now you can do service inheritance as well. So in the previous slide, you notice that the named list DAO extends Objectify DAO. So the only code I have to put in my named list DAO is code that's specific to that entity. In this case, I'm getting the user and setting an owner property. But if I were just persisting the entity, I wouldn't have to even have a method here, because it would just be inherited from the Objectify DAO. So you can make a really lightweight CRUD persistence layer using this. So service locators enable you to configure your services through dependency injection. And again, you can use one generic service locator for all services. Basically, all you need on the service is you implement the service locator interface, and you return class.newInstance. And it'll look at the service class that it was requested and just return a new instance of it. Or if you want to hook it into Spring or Juice, then you call like the web application context and get it from your DI container. So this is what an Objectify entity locator looks like. You can see it's very simple. The create method just calls class.newInstance to create an instance of the requested entity. And then the find method makes the Objectify call to find it. This one, I'm using Datastore object as a convenience. By extending that base class, having my entities extend that, I can know that the ID property is of type long, which makes my other methods in this locator a little bit simpler. But you can also do it using reflection, because it's on the server side, and avoid even that little bit. So your entities can just be plain POJOs, don't have to extend any class. So to sum it all up, to make a service layer with RequestFactory and Objectify, you have one entity locator, one service locator, one RequestFactory class. Those are for your whole app. And they're already written for you, by the way. If you look at the sample projects, we'll put up in a minute. And then your entity, each one has to have two representations, but one of them is just an interface on the client. Your service has an impl and a service interface. And that's about as lightweight as you can make a service layer, actually, in GWT. But even for this, we do have some tooling coming out. There will be a presentation sometime, it's either today or tomorrow, I can't remember, on using Android for App Engine development. App Engine for Android, well, anyway. And that presentation will be showing some tooling in Google plugin for Eclipse, where you can actually right-click and say new service layer or something like that, and it will create a lot of these interfaces and code for you. So watch this space for tooling to make this even easier. Okay, with that, I'd like to move to the front end now, to the UI. You've heard about the Model View Presenter framework, and several frameworks emerged, MVP for G, GWT Dispatch, GWT Presenter. And one of the most recent frameworks has been run by Philippe Beaudoin, who created it. And today we have, I'm pleased to announce, Philippe himself to talk about the framework. So welcome, Philippe.
Okay, so thanks, David. So the rest of this talk is going to be about the gwt-platform, which we also call GWTP, so we can have a cute little TP as our logo. Okay, so the goal of gwt-platform is to actually make it possible for you, the developers, to build a large-scale GWT application while sticking to the industry best practices. So in there, you'll get a presenter-centric model view presenter framework. There's also a common pattern that's included in GWTP and a couple of other goodies. For example, there are mechanisms to help you play with your internationalization strings or just recently in version 0.6, coming very soon, we'll actually have some mechanism to let you make it possible for your Ajax page to be indexed by a crawler. So I call this a presenter-centric model view presenter framework. And the reason is that because all the information is actually located right into the presenter. You don't have to write multiple classes. It's all in the same place. OK, so a quick overview of GWTP's MVP. First thing to know is that GWTP's MVP predates GWT's activity and places. So it's not based on them. However, we're working really hard to bridge that gap now so you can benefit both from activity and places and GWTP's super simple MVP syntax. So also, it's an annotation-based API, which means that most of the time you can do in a single line of code what would otherwise take you a couple of classes. There's also support for nested presenter, a little feature. We'll come back into details soon. And there's also built-in support for GIN, so you get dependency injection on the client, and much more, which we'll list at the end. OK, so in order to understand GWTP, let's start with a quick example. Let's say you want to build in your web app some page that welcomes the user to your app. So in MVP world, it means you have to write at least a presenter and a view. So this is how the view would look into GWTPs. So the first thing you'll notice is that we're extending some class there called ViewIMPL. It's important to know that ViewIMPL is an empty class, basically just providing default implementations for 3 methods. So you don't have to actually extend that class. You can extend whatever class you want, for example, composite. There's also, it's implementing some interface, and we'll come back to that soon. But really, the only important thing is that in that class here is the asWidget method you see at the bottom there. Basically says that your view has to be able to be represented as a widget. You can create that widget in any way you want. In that particular case, we're using UI Binder to create it. But if you'd prefer to use a GWT designer or to instantiate the widgets manually, you're free to do that. But the fun part is actually the presenter itself. So let's take a look at it. Here, the first thing you'll see is that we are defining the interface we introduced in the previous slide. So we have my view here. Right now, it's an empty interface, but we'll fill it with methods that the presenter can use to communicate with its view. We also have a second interface here called my proxy. The proxy is actually the fun part of GWTP. It's using GWT code generation tools in order to provide some kind of shadow class for the presenter. So that the goal of this shadow class is to actually make it possible for your presenter to be lazily loaded or to use GWT code splitting. So it's really easy to do code splitting with GWTP. You only need that line here, proxy code split, and your presenter will only be loaded the first time it's requested. And the last thing there is just a constructor that forwards all the resources needed by a presenter to the parent class who is going to deal with it. But you're free to use any of these resources if you need them. OK, so once you have a presenter, something you really often want to do is attach a URL to that presenter. So say the user visits my web page #welcome, you should get into that welcome presenter page. So in GWTP, again, that's easy to do. Single line, name token there, and you indicate the name token you'd like to attach to your presenter, and bang, as soon as the user visits that page, you get that presenter. Now, you often want to attach a bit more information to the URL. For example, let's say that here we wanted a parameter that on the URL that says, the username is Philippe. So you can do that again in GWTP, and it's easy because the URL is going to be parsed automatically by the framework. And once it's parsed, the framework is going to call a method called prepare from request, which you see at the bottom here. You get a place request. You can grab any component you want from the place request and do whatever you want with it. So you have the parameters there. In that case, we're calling a method in the view in order to set the username right in the view. So you can see we've added a method to the view interface at the top, and we're calling it from the prepare from request. Okay, now let's talk a little bit about GWTP's nested presenter feature. The idea of nested presenter is that it leverages the well-known principle of hierarchy of widgets that you all know and that you all use, and it tries to bring that all the way into the presenters themselves. So you can actually organize your presenters hierarchically without having to instantiate the widgets that are attached to them. So you're free to test your presenter hierarchy without having to instantiate widgets, so without the gwt test case. It also brings a couple of lifecycle events to the presenter. You will now have things like unreset, unreveal, and unhide, which will be called whenever these event occurs to your presenters, and all the way down your hierarchy. So let's say that you want a top-level presenter in your new presenter hierarchy. So the particular part, so this top-level presenter will actually have children presenters. In that case, the view has to be able to attach these children presenter to the parent presenter. And this is done in a method called setInSlot in the view. Basically, it only looks at the slot into which you want to add the children presenter, and it adds the corresponding widgets there. It's a really simple method. And this is only true if your presenter can have children. Otherwise, the view doesn't need anything more. Now, on the presenter side, since the presenter can have children, it has to define a couple of constants that will be used to refer to these children. So here, you can see two of these constants. The first one is called top slot and center slot. They have been added to the presenter. And these can basically be any kind of object. So the first one is a generic Java object. The second one is slightly more complex. It's a gwt type class. The reason the second one is more complex is because it's going to allow us to use the event bus to decouple even the parent presenter from its children. So the top-level presenter has to reveal itself and say, you know, I'm going to occupy the full page of the web app. So to do that, there's a reveal in parent method, which we left out earlier, but every presenter needs to have that. And in the case of the top-level presenter, it actually fires an event called reveal root content event. And that event is called by GWTP and says, OK, now the presenter is going to occupy the entire page. If you'd rather use gwt's layout panel, there's a slightly different event that you can fire in exactly the same way. Now, if you want to reveal a children presenter that's loosely coupled to its parent, they can't talk to one another directly. What happens there is that the children will actually fire an event again that says, please reveal me inside that slot. The slot is just a constant. It's not a reference to the parent itself. The parent will catch the event and reveal the children. The last little thing I'm going to talk about is called presenter widgets. So sometimes you don't really need to have that decoupling between the parent presenter and the children. You just want some lightweight mechanism to create reusable components. This is where presenter widgets come in. So presenter widgets are also very useful if you have tightly related presenters and you don't want to go through the trouble of decoupling it via the event bus. So an example in which I personally tend to use presenter widgets is a little login bar at the top of your web app that says, OK, well, you know, you're logged in, Philippe, log in, log out, stuff like that. So in that case, it's called the login presenter you see there. And for presenter widget, what we do is that we actually inject them in the parent presenter. So you can see the injection call here on the constructor. And then later, at any point in time, you are free to call the method called setInSlot and say, I want this presenter widget to actually occupy that top slot in that case. So in this example here, we're doing that in the unreveal. So the first time this main presenter is revealed, it's going to install the login presenter in the top slot. But you are free to replace it later or to do that at any time. So the last little thing is that we're using Gin, and all these nice little components are interfaces that we have to connect to implementations and that we have to connect to one another. This is done in the Gin module. There are a couple of methods in GWTP to help you do a lot of bindings in one call. So it's, again, a few lines of code. If you're interested to know how to do that, you can look at the wiki. Oh, there's also a custom place manager that you have to write. This is basically just telling your app, oh, if the user logs in without a hashtag there, go to that default page. Or if it's an error page, you can define it in there. So it's all defined in the wiki, like I said. But if you're using Eclipse, you'll be happy to know that with version 0.6, there will be a new Eclipse plugin coming out with GWTP that will let you create all these presenters and views and connections between them with a simple click of a mouse. So I'd like to thank Michael Renaud and Imagine, who have actually contributed that plugin. OK, so quickly, in summary, what GWT offers you is that basically you can do MVP with two classes, a presenter and a view, which is the strict minimum you need for MVP. There is also super simple history management through the add token annotation. You have nesting, so nested presenters. And there's also a lot more that I encourage you to explore. So you can actually have tabbed presenters with little tab at the top, or dialog box presenters. There are gatekeepers, which allow you to do client-side security, so some pages are not visible to some users. Proxy event is a little annotation that makes it super easy to bind event handler to events. There are breadcrumb support if your application needs that. Annotation processors that you easily automatically generate events, actions, and DTOs. And there's also the GWTP's comment pattern that is packed full of features like what we've seen. There's also a quick feature that I want to bring your attention on that's coming out really soon, too. It's what we call GWTP's crawler service. And basically, it's a service you can instantiate. Right now, it's meant to run an app engine. But it will make it easy for your Ajax page to be crawlable by search engine. It's a feature that has been requested for a while. I think is going to be really useful to you. So in conclusion, I'd like to thank ArcBees Consulting, who have been funding the project, also bookdin.net, who have been using it a lot, so really helped. But this project is an open source project, lots of contributors on it, and it would never be where it is today without their help, so I'd like to acknowledge them. So with that, I'll hand it over to David.
Thank you. Thanks very much. There's a couple of sample apps that I want to point your attention to for using some of these things. We have a project we created. Philippe did most of it, actually. The GWT+GAE 2011 project shows you how to use RequestFactory, Objectify, and GWT Presenter all together. GWT-Platform, sorry. List widget is something I did. The user interface is terrible, I apologize, but the server-side code is fine. Maven, Objectify, RequestFactory. And then TurboManage is my personal blog. ArcBees is Philippe's blog. Google Dev Tools is our Twitter account for the GWT team. Let's see. Sorry, I didn't get your blog up there, Jeff. The best place to find Jeff is actually on the Objectify App Engine mailing list. Based on the frequency and timing of posts that I've seen, I'm pretty sure that Jeff responds to the mailing list while he's riding his motorcycle to and from Central America, as he talked about in the abstract. So very responsive. I want to give a huge thank you to the open source community. We haven't mentioned them this morning, but I want to especially thank David Peterson, who created the GWT Presenter and GWT Dispatch frameworks based on Ray Ryan's talk 2 years ago. That framework was very important in building this whole community of MVP architecture in GWT. And GWT-Platform actually uses a lot of that code and is built further on it. So y'all are the secret to the success of these platforms. I encourage you to get involved in the open source projects around GWT and App Engine. And let's see. I just wanted to point out one historic thing that's happened here this morning. We don't usually let people talk at Google I/O until they're Googlers, or sometimes external guys like Jeff. But Philippe has done something unusual in that he's actually done his first presentation at Google I/O before he actually joined Google. He has been hired by Google, I'm happy to say. And his Noogler training isn't for a couple of weeks. Now, I'm a Noogler myself. I joined last June, so it was before the last I/O. So I just wanted to say, Philippe, my hat's off to you. Now, I want to point out one presentation where we're going to mention that RequestFactory tooling in the Android App Engine today at 3:45. Also, encourage you to stop by the GWT office hours from 12 to 3 both days. That's where you can get people personally answering your questions about GWT. And finally, I encourage you to visit the GWT Developer Sandbox area out on the second floor here. We have 16 companies who are using GWT in creative and innovative ways. And it's a great place to talk geek. There's also some of them, I think there's a special offer on a book there and some other things that you might be interested in as GWT developers. So let me, we have about 5 minutes left. If you would like to ask a question, can I ask that you make your way to one of the mics so that it can be on the video? And maybe that's not such a good idea with the crowd we have here, but if you can give it a shot. We'll wait for you to get to a mic there.
Yes, hello. I'm Didier Girard, and I have a question for Jeff. So, do you think that Objectify could be the next Hibernate? I mean, a kind of driver for NoSQL database, Datastore.
I don't know how to answer that question. I hope not. Hibernate is a very, very complicated piece of software. I hope Objectify never gets to that point.
Okay, anyone else? Yes?
Let's say I have variable schemas on the server side. Is there any way to apply the RequestFactory details if I don't know the schema of the object in advance?
No.
Okay.
Not offhand.
Okay. Thanks.
I mean, you can write a generic schema, but then at that point it just becomes basically a hash map or a properties bag or something that you're sending back and forth. It actually, I mean, that will work, and it will actually work with App Engine because the Datastore doesn't have to have types. As Jeff showed at first, you just have an entity, which is basically just a properties bag. So you can do it, but not with POJOs that you're redefining on the fly.
Okay, thanks.
Yeah. Question?
There, this question's for Philippe. Since Ray Ryan's talk, I really got into the MVP thing, and then with the activities and places, I kind of had trouble mentally mapping between that view of MVP and the activity places. Do you have any insights as to how gwt-platform is going to tackle that?
Yeah, to be honest, I haven't looked at activity and places that much myself. From what I understand there, it goes some way towards helping you do the MVP architecture, but you have to do the rest of it yourself. So, yeah, I'm not entirely sure. I think that what GWTP will do for you is that it will actually reduce the number of classes you have to write, just because it tends to use annotations instead of asking you to write multiple classes. Yeah, beside that, I'm not entirely sure how the difference between both.
We're going to talk about activities and places tomorrow afternoon in the High Performance GWT talk, and you might get some ideas there. I think you could create some, or Philippe could create some annotations for GWT, for presenters, for example, that would also allow that presenter to be an activity, and you could code generate some of the codes you need for that. We should talk. There's potential there.
I will be attending this one.
Yeah. Yes.
Hi, I'm Marcelo. Last year, I remember you showed us integration with the Spring Roo. Are the teams still working together? Are you going to add these to Spring Roo?
We haven't done a lot of development building further on Spring Roo. My understanding is that Spring has hired someone that is working on the GWT stuff full time. But I'm not real plugged into that right now, so I'm not sure how much is really going on. Yeah, that's about the best I can say. Just for curiosity, how many people are using Roo or trying to use Roo? A few people, okay. I'd be glad to get your thoughts. I'll be hanging around the developer sandbox area later today if you want to talk about that more. Any further? Yes?
Yeah, one quick question about, what about an Objective-C client for RequestFactory? I realize this is Google and we have Android as a client and GWT, but it's obviously a big platform, big market that would like to be able to deploy to multiple clients.
I'm sure if the open source community wanted to contribute an Objective-C client for RequestFactory, we probably wouldn't turn it down. But I don't think that's something that we would be working on. Okay, I don't see anyone else lined up at the mic, so thank you very much.